Hi everybody, welcome to 2.2, which deals with prime numbers, factors, and reducing to lowest terms. So first, let's introduce the term prime number. What does it mean to be prime? Basically, a prime number is any whole number that's greater than 1 that exactly has two divisors, or you can think of it as two factors, itself and 1. A divisor, aka a factor, is a number that divides a different number without a remainder. So let's say, for example, 4 has divisor 2, right? Because it divides 2 divides into 4 without any remainders. Okay, and also any number that's greater than 1 that is not prime is called composite. Okay. Let's do some super fun examples. So either these numbers are prime or composite. So let's take take a 10 seconds and see if you can tell me whether that's prime or composite. Okay, so 43 is prime, nothing else divides it other than itself and 1. 12 is composite because 4 times 3 is equal to 12, right? In other words, 3 divides it, 4 divides it. 100 is composite also. 100, there's quite a few. 2 times 50, 4 times 25, right? Okay, and 17 is also prime. So factoring into primes is called prime factorization. So the way that we like to do it, and you can learn it this way, or if you have another way to write it, I like to do a factor tree. Okay, and then we start off with 2 numbers and just keep going until the very ends of the trees are prime numbers. Okay, so let's see. So what are 2 factors of 60? So we could start here, 6 times 10, right? Then just continue. 6 has 2 factors. 2 times 3 is 6. And then 10 is 2 times 5. Okay? Now, 2 is a prime number, 3 is a prime, 2 is a prime, and 5 is a prime. So the way that we would rewrite 60, that's equal to 2, and there's 2 of them, so 2 squared. So 2 times 2 times 3 times 5 if I'm going from smallest to largest, or in other words 2 squared times 3 times 5. Okay, so that would be the prime factorization of the number 60. Okay, so a fraction is, now let's define lowest terms. A fraction is said to be in lowest terms if the numerator and the denominator have no factors in common other than the number 1. Okay, so this is in lowest terms, this is in lowest terms. We can't reduce it any further, in other words, to think about this. These are all lowest terms because they have no factors in common other than the number 1. We can't reduce this any further. Okay, is 6/8 in lowest terms? No, it's not, right? Because 6/8 can be reduced. I can divide top and bottom by 2. That gives me 3/4. And that's lowest terms. Okay? So now, the cool thing about understanding prime factorization is we can use that to reduce fractions into lowest terms instead of just like guessing or figuring out what divides into top and bottom. So let's say here I have 12/15. And I'm going to rewrite that, okay, along the top. So the factors of 12 in primes, right? It's 4 times 3, so it's 2 times 2 times 3. Okay, that's primes. And then 15 is just 3 times 5, right? So notice that the 3's will cancel out, and you get 2 times 2 on the top, which is 4, and then 5 on the bottom, 4/5. Okay. It's a lot easier to use prime factorization. The nice thing is that what you have left over will be in lowest terms because you can't reduce any further, and the way that you know that is because you use prime factorization to cancel things out. Okay, so 20. So if you want, you can go ahead and do the work on the side. So 20, you can write 20 here, right? 2 times 2. So this would be 20. 20 over 24. 20 factors into 2 times 5, right? And then if you wanted to do 24, what is that? 4 times 6, 2, 2, and then 2 times 3, right? So it's 2 times 2 times 2 times 3. So what cancels are the 2's, and what's left is 5 over 2 times 3, which is 6. Okay? Note that it's the same thing if you had taken 20 divided by 4 and gotten 5, and 24 divided by 4 and 6. Okay? So 6 over 42, that's 2 times 3 on the top, 2 times 3 times 7. So these cancel, but then what's left, if everything cancels out from either the numerator or the denominator, what's left over is that invisible 1. Okay, so this is the same as saying 1 over 7. Okay, and then 4 over 40, right? We could go ahead and write 2 times 2. This would be 2 times 2 times 2 times 5, right? 8 times 5 is 40. These will cancel, and you'd be left with 1 over 2 times 5 is 10, 1/10. Okay? And then 105 times 30. So let's go ahead and take the prime factorization of 105. We know that that's 5 times 21, and this is 3 times 7. So prime factorization of 105 is 3 times 5 times 7. And the prime factorization of 30, well, that's just 6 times 5, so 2 times 3 times 5. So the 5's will cancel out, the 3's will cancel out, and you'll get 7 over 2. And that's lowest terms. Okay, and that is pretty much it for this section. So that is your super fun homework, is section 2.2, 1 through 54, every other odd. If you want more practice, go ahead and do all the odds. That's better for you anyway. Okay, and I will see you on the next video.